We're going to be graphing this polynomial by identifying some characteristics like its root, the multiplicity on the roots, the behavior, whether it crosses or bounces off the x-axis. Then we'll find the behavior of the polynomial by finding its degree and looking at the leading coefficient, because that's going to tell us how the arrows look on the left and right hand side. So to find x-intercepts or roots, you have to set it equal to 0 and decide on a method in order to find those. I'm going to try to factor this. It has 4 terms, so I'm going to factor by grouping. First pair, make a group, and the last pair, make a group. So the first pair, I notice that they share x squared. What would be left would be x plus 2. Bring down your minus sign. Biggest number that divides 4 and 8 is 4. And what's left inside? X plus 2. Remember, for factor by grouping, the parentheses have to match. So my 2 factors then here would be the match in parentheses, the x plus 2. And again, if you shade those out, you're left with x squared minus 4. And I noticed that the x squared minus 4 can be factored further because that is the difference of squares. So x plus 2 is still a factor. In difference of squares, you open up double parentheses, you alternate the signs, one's a plus, one's a minus. And the first term, which is x squared, gets split in the front spots. So what can you multiply by itself to get x squared? X times x. And then the 4 gets split in the back spots. So what can you multiply by itself to get 4? That would be 2 and 2. So my final factor form here, I noticed that x plus 2 has a multiplicity of 2. So I could write x plus 2 to the second power and then x minus 2. We're going to be using this in order to fill out this next chart. So to find the x-intercepts, now that it's factored, all you're doing is taking each of the parentheses and setting them equal to 0, or you just flip the sign. So instead of a positive 2, it would be a negative 2. The multiplicity depends on the exponent. The multiplicity is 2 because it's to the second power. And if your multiplicity is even, it's going to bounce off the x-axis. My final root, all I'm doing is flipping that sign to a positive 2. It's to the first power, so since that is to the first power, the multiplicity is 1, and since it is odd, it's going to cross the x-axis. Now let's take a look at the degree of the entire polynomial. The leading coefficient is 1x to the third, so the degree is 3, because that is the highest exponent, and the leading coefficient was just a 1, and so that's a positive value. So since it is degree 3 and a positive leading coefficient, this is what your end behavior would look like. On the left side of the graph, it would be going down, and on the right side of the graph, it would be going up. So let's actually graph this. So I have an x-intercept at negative 2 right here, and at positive 2 right here. And I know the graph is down on the left side and up on the right side. So let's go ahead and connect this by reading how it's going to either cross or bounce off the x-axis. So at negative 2, it bounces off the x-axis. So we're going here, it hits it and bounces off. And then at positive 2, it's going to cross the x-axis. So here's my sketch. And again, we don't know how low it goes. We're just estimating here. And finally, I'm going to write my end behavior here, my end behavior in mathematical terms. So as x approaches infinity, so as you're traveling to the right here, it is rising. Your y values are increasing. So f of x, which is your y values, are going to infinity. And as x goes to negative infinity, to the left, your y values are decreasing. So as x goes to negative infinity, f of x, which is your y values, are going to negative infinity.